Hi, I'm Shubham Agrawal and I will present basics of vehicular communication using Wi-Fi. This tutorial will basically discuss about challenges in vehicular communication using a Wi-Fi connection, by which I mean a hotspot which is situated near uh, on the side of a road, which acts as an access point and provides a Wi-Fi connection or a internet connection to the moving vehicles. I will tell the difference between the normal Wi-Fi connection which users use in the corporate vicinity, and I will compare it and then discuss the shortcomings of the Wi-Fi connection when it comes to providing communication to a vehicular communication, a dynamic changing environment. I'll discuss those terms over here. So first of all, what is the prerequisite for this tutorial? Of course, you should have an understanding of 802.11 protocols. You should understand what is a Wi-Fi network and uh, how basically a Wi-Fi network is leveraged and utilized in a corporate environment. And yes, 802.11 tutorial is available in the site which we are talking, in which you have found this tutorial. So first I will talk about what is the vehicular communication. So move on the highway, remain connected via Wi-Fi. This is the basic analogy. So access point is situated at the side of the road and you have a car moving by, a vehicular car. I mean, this is just an extrapolation or shown to intrigue interest of you that car has an antenna on top of it, which may not be the case. As you can see in the figure over here, the car has two antennas. It may not be necessary. This is just a representation that car is moving and which has a internet connectivity, a laptop enabled, and this is an access point. And access point has an antenna, and this access point connects to this car, provides internet connectivity while the car is running. So this model can also be extended to a mesh network, in that case what will happen is this access point will be continuously available across the road. A bunch of these access points will be available and people will get a continuous connectivity. Or it may also be utilized in cases where this access point is situated, a single access point is situated, and people just want to move and get some data, just want to download their emails while they're moving. They're different places they are going and they're downloading their emails and moving. But these the scenario which we are considering is the access point situated in the side of a highway roads. So what will happen in that case, these cars will be moving at a very fast speed, and then you need to provide a reliable communication so that while they are moving they get connected, get the DHCP address. For example, they get a association request, get the DHCP request, get the IP address, transfer the data, get the data immediately, and then move on. And typically this whole area is supposed to be around 2 to 3 kilometers wide, which is a pretty good area, and if utilized properly, as I will show, can give a very good results and people will be able to download a lot of data. So this is the basic idea. Motivation: drive by uploads and downloads. While you drive you can upload and download data. You can upload pictures while driving. You are from some trip, maybe trip or Switzerland maybe, and now you want to share those pictures of your girlfriend to your friends, and you want to make them feel jealous of you. So you can upload those pictures while you are driving on the way. Download workup scores while moving. Wow, that's a great application I can think of. So here's the outline of this presentation. First I will talk about what are the shortcomings of 802.11 network, which does not allow, or which because of which there is a poor connectivity in this network. So as you can see, this connection is basically a Wi-Fi connection between access point and the car, but the typical 802.11 protocol which is currently available uh, uh, does not provide or is not able to sufficiently provide a reliable communication. I'll talk about the implementation. I will about a bitrate algorithm for I will discuss about that, and then I will talk results. I will discuss about why bitrate algorithm is important, what is bitrate algorithm, and how it is used. I will discuss about all that in this presentation. So coming to 802.11 shortcomings. Uh, as the requirement of this tutorial is that you should understand what 802.11 is, so I assume you understand what fairness is. Just to brief about it or refresh about it, 802.11 network has fairness inbuilt in it. By this, what I mean is, if some person is having a data rate of, so 802.1, the 802.11 protocol tries to provide you equal amount of throughput, or you can say good put, for all the clients. It's fair. So none of the client which is connected to a Wi-Fi network will be able to get more throughput than another client in a very significant manner. It tries to give you almost equal throughput, so it divides the time sharing in such a manner so that if one client is fast and one client is slow, then the slow client will take more of the time and fast client will get less time, and hence there will be equal amount of data transferred to both the clients, which is actually known as anomaly effect. So let's discuss about what the effect is which I am talking about, and after that I will talk how it is related to a vehicular communication model. So access point is situated over here, as you can see, and these are different zones of link speed. As you can recall, in 802.11 network there are different zones. The zone which is closest to the access point is having a maximum bitrate. For example, if you talk about 802.11 G protocol, then this will be 54 Mbps, whereas a zone like this will be 48 Mbps, and so on. There will be lot of zones, and suppose this is a zone of 1 Mbps. Now what will happen in this zone? This is a fast client. It has a connectivity of 54 Mbps. This connectivity of 54 Mbps is a MAC layer connectivity, right? So it can transfer a data up to rates of 54 Mbps at MAC layer, whereas this has connectivity of 1 Mbps, so it can transfer a data at speed of 1 Mbps at MAC layer. And this client, actually, if you talk about throughput, then this client will have a maximum throughput which are theoretically practically verified to be 33 Mbps, and this will have maximum throughput achievable in a 802.11 network is 33 Mbps. Let's forget about that and talk about what now anomaly effect is. This client is 54 Mbps, this client is 1 Mbps. Now because this client is slow and hence will take more time to transfer data, and this client will take less time to transfer data, this 802.11 scheduling algorithm will distribute in such a manner that this fast client will actually become slow, which actually means it will keep on transferring data at 54 Mbps at MAC layer, but total throughput achieved will be equal to total throughput achieved by this client. So they will divide time equally in fairly, which may not be fair but for this guy, but this is fair for overall network. So this guy will have less time transferring data, this guy will have more time transferring data, and hence this slow guy will make this fast guy slow.